Hi everyone, this is Sushant from Unity Devs. So guys, welcome to our today's session where we will understand about for each and parallel for each scope in Mule 4. Okay, so first we will cover some theoretical part and then we will cover some use cases, some practical real-time use cases which I have prepared in my Anypoint Studio. Okay, so let's start with the theoretical part of for each, guys. So guys, what is for each basically? Okay, so this is the definition of for each. So it is written: for each scope splits the payload into elements and processes them one by one through the components that you place in the scope. Okay, so it is similar to that of a for each loop we use in most of our programming languages, guys. Okay, and a collection can be anything. It can be a Java, it can be a JSON, it can be a XML. So let's say we have a collection of array having multiple elements. Okay, so with the help of for each we can process those elements. Okay, so that's how this for each works. So it will process those elements in a sequential way. Okay, so it will process a particular element and the next element and the next element. Okay, so that's how it works, guys. Okay, that's the basic definition of for each. Okay, moving on to the next topic, which is variable propagation in for each. Okay, so guys, in this topic we will understand how these variables will act. Okay, let's say we have some variables defined before for each. Okay, and similar variables we are modifying inside for each. Okay, so after processing those records, what will be the value of those variables? Okay, after processing everything in the for each. So that's the concept of variable propagation. Okay, so it is written: every execution of a for each scope start with the variables. Okay, so if we have defined any variables and values from the previous execution of a block, new variables or modification to the existing variables that take place while processing one element are visible during processing the another element, guys. We will understand this more clearly while doing some practical use cases, while running some practical use cases. Let me go to Anypoint Studio and show you how for each works. Okay, so guys, you can see these are the use cases I have created to understand the for each scope, and these are the two use cases I have created to understand the parallel for each. So our first topic is for each, so we will execute these for each use cases and understand how it is working. So guys, this is the listener used to listen to the requests, which I will trigger from postman. Okay, after that I have initialized one variable. I have defined one variable where I have assigned color value as red. Okay, and after that I am reading some data from the file. Okay, so there is a collection in that file. Let me show you that collection. So guys, this is the collection of student data we have. Okay, so this is an array having 3 objects. Okay, so it means for each will iterate 3 times. Okay, it will first execute the first element. In the next processing phase it will execute the second element, the second object, and in third processing phase it will execute the third element. Sorry, there are 4 objects. So in fourth processing phase it will execute the fourth element, fourth object. Okay, so there are 4 iterations inside the for each. Okay, so we will see how it works. Okay, so guys, we are reading that data which I have showed you in the VS Code. So after reading that data it will process those 4 objects. Okay, just like we used to write a for each loop in most of the programming languages. So one by one it will iterate each and every element. Okay, so you can see we have defined one condition. If color is equal to red, it will go inside this flow. So what it will do, it will first log that color name, and then it will write whatever payload will come here into the file. The file name is output.json. Okay, and then it will change the value of that variable to blue. Okay, so guys, what I'm trying to explain you here is that when this variable, this same variable name, we are using the same variable name in this flow. So when that variable value will be changed to blue, okay, so in the next processing phase, when this for each will process the next element from that array, okay, after completing the first processing of the first element, when it will try to process that second element, that variable value of that color will be blue. It will not change. Okay, so in next processing phase it will not change, it will be blue. So this condition will satisfy in the next phase, next processing phase of next element. So because this condition will be evaluated true, so it will log that color name, it will write into the file, okay, and then it will again use that variable name and assign the value as let's say green. Okay, so this time the value is green. Okay, so in a next processing phase, while processing the third element, that variable value of that color will be green. Okay, so that variable value has not changed. Okay, okay, so that variable value in that second processing phase will be changed to green, and in the next processing phase that value will be green, so which is the third processing phase. So when third processing phase will happen, when the third iteration will happen to process that third element, at that moment the color value will be green, so it will process this flow, but this time the value will be changed to violet. So the new variable value is violet, okay, in the third processing phase. Okay, now when fourth processing phase will occur, when the fourth iteration will occur, the variable value will be, the color variable value will be violet, so it will not satisfy any of the conditions here, so it will jump to the default flow and it will execute it. Okay, and this time we have specified a color value as orange. Okay, so in the last processing phase, in the fourth processing phase, the color value has changed to orange. Okay, so because it's changed to orange and all the iterations are complete, so in the last we will get a variable value as orange. Okay, the latest updated value of the variable. Okay, so guys, let me run this application and show you how it's working. Okay, let me debug it. Guys, the application has been deployed. So let me trigger this flow and show you how this for each will work and how that variable propagation concept will work, which I just showed you previously. Okay, the variable value changes in each iteration. Okay, so let me trigger this flow. So we'll trigger that flow, guys. Okay, I've clicked send. So you can see it reaches the for each, and the payload value is the payload which I showed you. Okay, which we are reading from a file. Okay, with the help of this read connector. So we got the payload from that file, a list of students having student name, ID, student age, address, school name, and student marks. So guys, because it's a collection of 4 elements, there are 4 students in this, 4 objects I can say, so it will iterate 4 times. Okay, sequentially. First it will iterate to first element, Like in the next processing phase, it will iterate the second element, this one. In third processing phase, it will iterate this third element, and so on. And then last iteration phase, it will iterate this fourth element. Okay, so one by one we will see how each and every element is iterating sequentially. Okay, so if I click on next, okay, so the color red condition has been satisfied, which we have set initially. So it goes to this flow and it will log this color. Okay, so you can see in the logs, color red has been logged. Now it will write into the file, whatever file we have specified here. So what it will write? It will write this first element, first object from that array, which we saw. So this first student name is Tom, ID is 34. Okay. So the first element is name student and ID is 34. Okay. So it means for each is iterating the first element. Okay. If I click next, so it has written into the file. Let me show you that file. So guys, so this is the file. So you can see that student name has written now in this file. Student name Tom and that same ID which we just saw. Okay, so write operation is successful, guys. Now you can see this variable value, that same variable name. Okay, but the value has been changed to blue. Okay, so if I click next, okay, here it will log that payload. If I click next, so guys, in this next iteration phase, so you can see the variable value has changed to blue. Okay, in previous iteration it was red. Now it is changed to the blue because in previous iteration we changed that value to the blue. Okay, so as you can observe this behavior, so the value modified in the previous processing phase, previous iteration, is available in the next iteration, so it has not changed. Okay, so now in this iteration, if I click next, you can see that condition has been satisfied because we changed that variable value in the previous iteration. Okay, so that value persists in the next processing phase, in the next iteration, guys. It has not it has modified in the previous iteration phase and the same value is available in the next iteration phase. So if I click on the next, guys, you can see the value of blue has been logged successfully. Okay, so if I click next, it will write into the file. What it will write? It will write the second element, this second object. This is second student name Harry, IDs 20, student age, address, all these things it will write into the file. So a write mode I have selected as overwrite because I'm using the same file, okay, in each and every iteration. Okay, so that's why I've selected write mode as override. So it will override that previous value of Tom. Okay, I will show you. So if I click on next, now if we go to that, so you can see, guys, the value of that student has changed. This time the student name is Harry, ID is 20. So this is that second element of that array which I showed you previously. Okay, so you can see this is the second element which has been iterated. So guys, now you can see the value of this variable has been changed to green. Okay, in this second iteration. So if I click on next, again next, now the third iteration phase will start. Now in this third iteration phase, a value of variable is now green. Okay, because that same variable value was changed to green in the previous processing phase, in the previous iteration. Okay, when we were iterating that second record. So now the variable this color value has changed to green. So if I click on next, it has satisfied this third condition, that if color is green, go to this flow. Okay, so guys, now it will log that color. Okay, let me show you. Now you can see the color is green. Now if I click on next, it has written into the file, okay, that third student having ID is 22, but student name is same, but ID is different. Okay, so let me show you that file. Okay guys, so ID has changed to 22, student name was same. So in the third iteration phase, it has written that third record into the file. Now guys, that variable value, that same variable has changed to violet. Okay, in this third iteration phase. So in the next iteration phase, you will get variable value of this color as violet. Okay guys, so because we didn't specify any condition of color as violet, that if color matches violet, so we didn't specify any condition like that, so it will go to the default flow. It will log that color name. Okay guys, so you can see the color is violet. I click on next, that fourth element has been written into the file. So that fourth element is Tom, having different ID. So the initial element was also Tom, but that ID was different. So that first element ID was 34. Okay, but this time this next element, this last element ID is 36. Okay, so students having same name, but there is a different ID, so it has written that fourth record into the file, guys. Now this time the color value will change to orange, but because we didn't have any iterations left to process, okay, so the final value of this variable will be orange. Okay, so if I click next, okay, so all the iterations are completed. Now it will go to the last logger because the processing has been completed. Okay, and it sequentially processed each and every record, not parallelly, sequentially, with the help of only one thread. Okay, so it's a sequential behavior of for each. Okay, so guys, you can see it has reached the final value, final logger, because all the elements has processed successfully. So in the final, once it reaches that final logger, what will be the value of payload? The value of payload is the same value which we have supplied before hitting this for each. So after read from this, after performing a read operation from this file, whatever payload we got the same payload while after processing all these 4 records. So the payload value has not changed, guys. Okay, so while processing for each, payload value will not change. Whatever payload value before processing for each you have, that same payload value you will get after processing through for each scope. So you can see that payload is same payload which we have before processing through for each after a read operation, guys. So if I resume it, this whole operation completes. So guys, I hope you understood everything about this for each. Okay, now there is one question I think which you have, that what if any processing phase or any iteration phase fails, what will happen? So guys, I have prepared one use case for that scenario also. Let me show you. So this is that use case. What if any iteration fails? Okay, so guys, in that phase for each will stop processing if any iteration fails. Okay, so let me show you how it will work. So I have used that previous flow. It's almost same, but in this third condition, when color is green, it will raise error because I have specified a different extension which doesn't exist. So it will not able to look into that file. It will not able to detect this file, and it will throw error. Okay, and after throwing error, this execution will stop. Okay, so let me show you how by triggering this flow. Okay, but before triggering, let me change the variable values. Guys, this video might be a bit long, but we have covered each and every concept regarding both for each and parallel for each. Okay, okay guys, so I have changed the values. So let me deploy my application and trigger this flow from Postman. So guys, the application has been deployed. Let me trigger this flow. If I click send, okay, so it is iterating the first record. This for each is iterating the first record. Now if I resume it, now it's iterating the second record. If I again resume, it is iterating the third record. So now while iterating the third record, it will throw the error, okay, because that location doesn't exist. Okay, so there is a illegal character, but doesn't matter, it throws error. It can be any error. Okay, it throws the error, and so now we will see what will happen. If I click next, it goes to the for each level, higher level, and it stops. It has stopped processing, okay, in the middle. So it didn't iterated that fourth record. Okay, so if any error occurs while iterating any record from the collection, it will stop processing simply. Okay, so to handle those errors, you can add some error handling strategies, okay, based on the use case you have, based on the scenarios you have while working on the projects. Okay, so here I can add some error handling strategies, that if any error happens, what will you do? Okay, so guys, if any error occurs while iterating any records, I will log something here. Okay, so based on the different use cases, based on the different scenarios you have in your project, based on that you can add your own error handling strategies. Okay guys, so it might differ in different scenarios or different use cases, it might differ. Okay, this is just to explain you. Okay, whatever error handling I'm doing here, it is just to explain you, but it might differ based on the different use case or different scenarios you will work. So I will write error occurred while processing records. Okay, I will save it, put some debugger point. Okay, let me wait for deployment. Okay, so application has been deployed. Let me trigger this flow again. So if I resume, it will iterate the next record. Okay, now if I resume again, it will iterate that third record. Now it will fail. Okay, it will go to another propagate. Now it will log a message that hey, some error has occurred, and it will stop processing the remaining records. Okay guys, so you can see the console, the error has been logged. Error occurred while processing records. Okay, and you can also set this message level as error. Okay, that is very useful, the best practice. So when they will so it is basically helpful while filtering if application has any errors. Okay, so if you are logging any error, it's always the best practice to specify your logging level as error. Okay, okay guys, so I hope you understood everything about this for each concept guys. So let's move on to the next topic, which is parallel for each, and in the end we will also understand what is the difference between for each and parallel for each. But before that, we will understand what is parallel for each, okay, how it works. Okay, then in the last we will understand about parallel for each, difference between for each and parallel for each. Okay, so similar use cases I have prepared for parallel for each too. Okay, but before directly going to jump to the use cases, we will understand some theoretical part. Okay, in that way it will be more easier to understand how this parallel for each will work. So guys, let me cover some theoretical part regarding parallel for each. Okay guys, so in the definition guys, it is written the parallel for each scope enables you to process collection of messages by splitting the collection into parts, okay, that are simultaneously processed in separate routes within scope of any limitation configured for concurrent processing. And after all messages are processed, the results are aggregated following the same order they are before the split. Okay, so guys, basically whatever collection you will get, whatever array of records you will get, it will first split them. Okay, it will first split them into parts and process those records parallelly. We saw in for each it was executing sequentially one by one, but in parallel for each scope it will execute all, it will split those records first from the collection and process those records parallelly based on the number of threads we have in our computer. Okay, we can also change that thread count using max concurrency field configuration. Okay, so by default it will use the maximum level of threads we have in our computer based on the number of cores, guys. Okay guys, so that was the basic definition of this parallel for each. Let's move on to the next slide. Okay, so these are the two most important configurations based on the requirements you can do. Okay, but if there is no requirement, you can also discuss with your architect or a principal architect that if these configurations can we do or not. Okay, so by default it will use the maximum number of threads we have in our local machine. Okay, based on the number of cores. So but even if you want to specify some thread count, so with the help of this max concurrency field you can specify some thread count. Okay, so with the use of those number of threads it will execute your records parallelly. So if you specify 5 threads, so it will execute 5 records, those 5 parts, okay, from that collection parallelly. If you specify 10 threads, it will process 10 records, 10 parts parallelly from that collection. Okay guys, so this is max concurrency basically. So the next field is collection. So collection is nothing but incoming payload. Okay, incoming payload having a collection of elements. Okay, you can also specify some value that where is the collection. Okay, you can point to that collection using this collection configuration, but by default it will pick the collection as payload, the incoming payload. Okay guys, these are the basic configuration details of this parallel for each. Let's move on to the next slide. Okay, so the parallel for each variable propagation. Okay, so guys, the first point it is written, every execution of parallel for each scope starts with the same variable and values as before the execution of block. So whatever variables we have specified initially before executing the parallel for each, that same variable value will be available for all the elements which parallel for each will execute parallelly. Okay, so that variable value will be same across the different elements which parallel for each will execute parallelly. Okay, so variable value will not differ. As you saw in a previous for each concept that whenever we were changing the value of variables in the first iteration, that same variable value was visible in the next iteration. Okay, so after modifications those variable values were visible in the for each, but in parallel for each that's the opposite case. Okay, so whatever variable values you have initially, that same variable value will be visible across different elements that are executing parallelly in for each, in parallel for each basically. So guys, the second point explains this concept more clearly. So in the second point it is written, new variables or modifications of already existing variables while processing one element are not visible while processing the other element. Okay, so whatever modification you will do while processing any one single element in that particular variable, that modifications will not be visible while processing that other element in parallel for each. Okay, so which is the opposite case of for each. In for each it was visible, those modifications were visible, okay, in the next iterations, but in parallel for each those modifications will not be visible in the other elements. Okay, so guys, that was the very big so guys, that was the very big difference between this for each and parallel for each. Okay, so guys, let me go to the Anypoint Studio and perform some practical okay, tests on parallel for each. Okay, how it works, so that you will get some more understanding. Okay, so let me go there. Okay guys, so these are the two use cases which I have prepared to understand parallel for each concept. So this is the use case 1 and this is use case 2. Okay, use case 1 first I will open. Okay, so the endpoint name is UC3. Okay, and listener configuration I have specified as 8081 localhost. So from local I will hit. So from local I will trigger this flow, guys. So all the components are same as that of the previous flows in the for each we saw. So we have a color variable having red color. Okay, and then we have the only difference is the scope. This time we have parallel for each scope. Okay, so basically you can drag it from here, from palette. You just need to write for, then you can see these two scopes, for each and parallel for each, guys, and you can just drag it here in your studio. Okay, so guys, we have this initial value of the variable as red. Okay, so this color variable value is red. Okay, so I have used the same flow which we saw previously while executing the for each. We have this read connector where we are reading that collection from a file. Okay, that file is this one. Okay, so this collection has 4 records I showed you previously. Okay, so these 4 records will be executed parallelly, guys. Okay, because it's a parallel for each. Okay, it will execute those 4 records parallelly. Okay, okay, so let me trigger this flow and understand how it's working, guys. Before that, let me change these values. I think it's already there. Okay, I think it's correct only. So let me trigger this flow. I've also added some delay elements. Okay, to just show you how it is processing these 4 different records parallelly. Okay, so that's why I've added some delay. So let me trigger this flow, guys. Let me deploy this application first in the debug mode. As the application has been deployed, let me trigger it from the postman. Okay, so you can see we are reading from a file. We are reading the same payload which we have previously while executing a real-time example using for each. Okay, so that payload looks like this, having a array of 4 records, having array of 4 objects, having 4 different students. Okay, so if I click on next, okay, you can see this payload we have read from the file. Okay, so and because collection we have specified as payload, so it will pick this payload. Okay, split it and execute it parallelly. Okay, so if I resume it, okay guys, so it has executed all the 4 records successfully. Okay, so guys, why it is printing first flow? Okay, why it is printing only this logger? Why it is not going to this one? Because we changed the value of this to blue in the previous processing. So that's the trick here, guys. So as I showed you previously in the variable propagation concept, so whatever initial value of variable we have defined, okay, that same variable value will be visible to all the 4 elements which we have. Okay, and a variable value changed in the one processing of one element will not be visible while processing the other elements. So the same variable value is red is visible across all the different elements. So that's why it only executed this first flow, guys, and that's why we are seeing only this first flow. Okay, so that's how this variable propagation and parallel for each works, guys. Okay, okay guys, I hope you understood about this parallel for each concept. Okay, you can also specify some number of threads. If you want to process 2 records parallelly, you can specify max concurrency as 2. Okay, so I hope you understood, guys. Let me explain it to you with the help of one more example where we will understand what if any error happens while processing. Okay, I will use this same flow which I processed previously to avoid confusion. Okay, so what I will do, okay, so I will so guys, I will put one logic here to show you what happens if it fails. So I will add one condition. If or you can simply say that payload dot id is equal to if payload dot id is equal to 36, it should fail. Okay, it should fail. So to fail it, what I will do, I will raise one error with the help of raise error component. Okay, so if id is 36, it will fail. Other IDs it will process as it is. Okay, so let me configure one custom error. App record failed. Okay, this is the custom error I have configured, guys. Okay, so once it encounters this ID while processing those 4 elements parallelly, okay, it will fail. It will raise error, but it will not stop executing the remaining records. It will execute the remaining records, and in final it will provide an error that hey, this some error happened while processing those records. So let me show you how it will work. Let me trigger this flow and we will see how it is working. Okay, so I think it's already deployed. Okay, let me trigger this flow again. Okay guys, so you can see the flow has been triggered. If I resume it, okay, so we got an error because this time the ID is 36. Okay, so remaining records are processed, but we got some error here. Okay, so in the last we will get, guys, you can see we got an error. So it's saying an error occurred while executing the third route. Okay, why it is saying third route? Because third is the final route. Okay, 0th route it is considering as the first route, this first record. First one route is, it is considering it as second object, this second record. Okay, 2 it will consider as this third record, and 3 it will consider as this last one. So that's why it is saying we got an error while executing the last record, because in last record we have specified ID as 36 and raised some custom error here. Okay, you can see we have specified ID and raised some custom error, but it processed the remaining records. Okay, but in the final it provides error description that hey, the last one fails. Okay, so guys, that's how this error thing works in the parallel for each, guys. So guys, let's consider let me go to the presentation. Okay, so guys, in the slide it is written for in case of parallel for each, because every route is processed in parallel. So if an error is thrown in one route, processing will continue in all the other routes until all finish processing. So after that, all the results, if any, even if any error occurred, are aggregated and then processed by the error handler as shown. Okay guys, that's what we saw. Okay, so it continued processing the remaining records, but in the last it provides a description that hey, that last one fails. Okay, but it didn't stop the processing the remaining ones, it processed all of them. Okay, it finished the processing, and then in the last it provides us a description that hey, that last one fails. Okay, if 2 of them fails, it will provide that hey, that the last one and second last one fails. Okay, so guys, that's how this error handling works in the parallel for each. But in for each, if any route fails, if any iteration fails, it will stop processing. So that's the very big difference between this for each and a parallel for each, guys. So guys, I hope you understood everything in this session. So if you got any use case, if you got any project where there is a need to use this for each or parallel for each, I think you will able to use it very easily. Okay, thank you guys, thanks for watching this session. Okay, please subscribe our channel to get the latest notifications, and please like it. Thank you guys, bye, we will meet soon.